My name is Minna and I'm working as a senior scientist at the Technical Research Center of Finland, VTT. My main expertise areas are investment management and appraisal. In the Megaroller project, I have been involved in the task related to assessing the life cycle cost of the Megaroller device. And this has been a close cooperation between VTT and AW Energy during the Megaroller project. Today, I will give you a short overview of the life cycle costing, and then I'm going to say some words about the role of the life cycle costing in wave energy sector, and then I'm going to finalize with a couple of words about what we did in Megaroller regarding the life cycle costing and analysis. So let's start with the LCC in general. So what is actually included in life cycle cost and how the life cycle cost can be calculated? Here you can see some figures. If we think about the life cycle cost, it can be defined to be all the cost that occurred during the life cycle of the system or a product or a process. And here in the figure on the left side, you can see the main cost components of the LCC, the CapEx and the OpEx. The CapEx is the capital cost and includes development and investment costs. And then the OpEx is the operational cost which are occurred during the operational time of the system. So that's why it's called OpEx, operational and maintenance cost. And here you can also see the very common iceberg figure which visualizes the concept of the life cycle cost. So on the top there is this acquisition price or kind of investment cost, the CapEx. And then the bottom is the OpEx. And there are very many different types of costs. And typically in the cost assessment, the investment, the CapEx is emphasized and the OpEx is not so much research in detail. That's also because there are a lot of more information regarding the CapEx than OpEx. And what was the very important factor in the Megaroller project is that for example, when we are thinking about the maintenance of the wave energy technology, for example, the offshore maintenance can be very, very costly, and it's very important to take that into account already in the design phase. And what is also evident that the major part of the life cycle costs are committed already in the design phase. That could be typically already 80%. So it's very important to do the life cycle cost analysis already in the design phase. And that is exactly what we were doing in the Megaroller project. And the process that we followed in the Megaroller is following the process that is presented in the standards, IEC standard and ISO standard. And here you can see the main steps of the life cycle costing. And in general, life cycle costing is a method to compare alternative solutions and to assist decision makers in selecting the most appropriate options from the economic cost point of view. And here you can see the 4 main steps. The first one is the structuring the decision, where the case for the assessment is defined and also with the framing conditions. And in this case, that was the Megaroller device. And after that, the second step is the cost identification and defining the most important KPIs, the key performance indicators. And the very important part of the LCC analysis is the defining of the cost breakdown structure. And this was exactly what we were doing when we were cooperating with VTT and AW Energy in Megaroller project. And then there are, of course, a lot of different calculation parameters like life cycle, the length of the life cycle, and for example, the discount rate. And then the crucial part is, of course, the analysis performing, where the data is collected and the costs are evaluated, and when the results are calculated. And when we are talking about the novel technology, like wave energy technology, the very important part is also the sensitivity analysis. How sensitive the costs are and what are the cost drivers. How we can find the cost drivers and how we should change the designs or the maintenance or operating strategies. Okay, that was the basics. And then we could continue to discussing a bit about the LCC in the wave energy sector. So what is the role of the LCC in the development of the wave energy technologies, and how can life cycle cost evaluations and calculations benefit the wave energy technology development? So what is the role in the wave energy sector? So especially life cycle costing, it increases the understanding of the economic impacts and increases the cost awareness when we are developing and designing the wave energy system like mega-roller device. And the other thing is when we are developing the implementation strategies and paving the way for the wave energy to be competitive with the alternative forms of electricity generation, for example, the offshore wind and solar energy, for example. And what is also evident is that at the moment wave energy is still in the earlier stage of the technological development than, for example, the wind and tidal energy installations. And this also indicates that both the capex and opex are considerably higher. And here in the figure you can see the main cost components related to wave energy. For example, when we are talking about the capex, there are costs related to device, foundations, connections, installation and decommissionation. And then when we are looking at the opex side, then there is this maintenance, both preventive and corrective maintenance, and then operating, and then insurance, lease and transmission charges, for example. And then the other aspect is that if you would like to calculate the levelized cost of energy, which is the total life cycle cost divided by the energy production, the relevant factors there are also site resources, device performance and availability and reliability. Here in the graph you can see the typical cost breakdown by cost categories for early wave energy systems. So here you can see the role of the capex and opex. What is the typical for opex and capex in these contexts? So as you can see from the figure, the device structure and the power takeoff is very high cost element category, and then of course the opex. And how then the LCC, when we are looking at the wave energy development, how it contributes to the wave energy? So it contributes to cost reduction by identifying the cost drivers. That could be very different, but they are very important to find, and it also brings very many other issues in the discussions. For example, the dependability, reliability, sustainability, safety, and societal considerations. So what would be the cost impacts and when we are optimizing the reliability and trying to minimize cost impacts, for example. And then the main thing is that the LCC in the wave energy sector, it supports the designers to make the transparent and systemic decisions and creates a common understanding of the cost impacts of the various design options before the actual actual decision takes place. And when we are thinking about how to reduce the cost impact, how we could reduce the cost of the novel wave energy technologies, there are many ways how we can achieve that, and which need to be taken into account. So one thing is that when the technology improved and the performance improved, and when there are more standardized processes and components, then there could be like more reduced costs. And then of course there is this economics of scale. When we now are thinking about the 1 megaroller device, and then later there could be this kind of wave energy park when we can allocate the cost for the whole park. And by increased competition and deployment, the experiences, we got more experiences, and in that way the risk also reduces. And then there is of course always possibility to share synergies with the other offshore sectors, and that's a very huge opportunity also, and needs to be taken into account if possible. Okay, then I will finalize with the LCC in the Megaroller project. What we did in Megaroller and what are the main results. So in the Megaroller, we both made the LCC analysis of the Megaroller device, and then we developed the tool that supports the LCC assessment. And we also used the tool when we make the life cycle cost analysis. And as I already mentioned earlier, our process is following the guidelines in the standards, and what can be done with the tool. It can be used to assess the cost through the entire lifetime of the Megaroller device. And what is very important feature of the tool is that we are able to make the cost scenarios of various Megaroller designs, for example, or various operation and maintenance strategies and failure situations. So regarding the analysis, we first defined the really detailed cost structure together with VTG and AW Energy, and that this cost structure is also included in the tool, and here you can see the very high level structure of the cost. So we modeled the capex. There we have the investment cost, which is in this case the Megaroller device, PTO panel, foundation, etc. And then there are of course a lot of infrastructure related cost for Megaroller. And the other capex is the assembly and submersion cost, what needs to be done in this phase of the project. And then there are of course other capex, and in the end of the life cycle there is this decommissioning cost. For example, how we could reuse for example the foundation. And then in the OPEX side, we have costs related to operating and monitoring. For example, the remote operating cost, the data transfer and storage, and then also consumables costs. And then of course there are very many maintenance related tasks. There are kind of minor maintenances and inspections that could be done onshore, and then there are these kind of major periodic maintenances that are doing offshore. And then there is kind of a failure module also in the tool that is based on the FMECA results, that is linked to the FMECA, where the most critical failures were identified. and that in the cost tool, in the life cycle cost tool, the direct cost related to work and spare parts of the failures were assessed, and then of course then also the lost revenue that is related to failures when the failure, if the failure occurs. And then there are other operation and maintenance costs also. And in addition to that, we also made a kind of additional failure tool that is included in the sensitivity analysis section of the tool, where there is a possibility to make scenarios for additional failures and to visualize the cost impacts of them. Yes, that was the one thing. And what we also did in parallel when we were developing a tool and making the analysis, we of course needed to gather the data. So there are very many data sources that we used. We used, for example, the results of the earlier research studies. We used the industrial reference data. We used statistics and other data bases, and then we of course we discussed a lot with the AW Energy and used the data they had gathered. And then when we are now talking about the novel technology, we of course also needed to make some expert judgments regarding, for example, the future operation and maintenance strategies and related costs. And I will end up with the main user interface, the home screen of our tool. So here you can see it. So it covers all the modules I just explained. There is this CapEx, where the mecharoller system and infrastructure costs are defined based on the cost structure we have, which is included in the tool. And then there is this final assembly and submersion cost, and the equipment and work cost related to that. And then there is this OPEX, which is remote operating, inspections and minor maintenance, major periodic and flotation maintenance, and then there is this failure module. And in the beginning of the process, we are also defining the calculator parameters for the assessment. And then the results and sensitivity analysis sector is very important. So the results section is defining and presenting the results both in the numerical form, and then there are a lot of graphs that could be that are available for the key KPIs, which are the total life cycle cost, CapEx, OPEX, and the cost related to these cost items that are defined. And then by using the sensitivity analysis module of the tools, the various cost scenarios can be illustrated, and the impact of the various designs or various operation and maintenance strategies could be visualized. For example, what could be the interval for the major maintenances, and what kind of cost effects it had. And also there is a possibility in the tool to print out the result summary of the analysis. Okay, so thank you. And if you have any further questions, I would be happy to answer them, and you could contact me, for example, by email. So thank you very much. So one very important question is that what is the cost effect if we have one device or if we have a wave energy park? So that's very good question. So when we are thinking about both the CapEx and OPEX, so regarding the CapEx, of course, when we have the wave energy park, we could allocate and divide for example, the infrastructure cost for the whole park, not for the one device. When we, for example, think about the grid connection and things like that, and all the infra that is needed. And then regarding the OPEX, there is a lot of cost there is a lot of possibilities to reduce the cost and to make the operation and maintenance more cost effective when we have more devices than just one when we are going forward to the wave energy park. And regarding the future wave energy, the wave energy park are the part of the very essential part of in the development process. But first we need to have the device. Yes, thank you.